How are you?
I'm good. I'm good.
Okay. My name is Pen Xiang. I'm the intern in BIAD, Beijing Architecture Design Institute. Please be free. And I have prepared three questions for you. Yeah,
Okay,
yeah,
let's
yeah.
kick off.
Right. Thank you. It feels like Zahadid's previous work is quite different from Zahadid architects now, such as the architectural language or styles. Usually, we thought Zahadid as a deconstructivist, but now the works of Zahadid's architects is more like modernism. Um, so what I'm interested is the difference and what causes the difference.
Well, first of all, let me correct you. I think that the current work of Zadid architects is not modernism.
Uh-huh.
It is what I call parametricism, and some of our latest buildings fall under the style that I have been calling tectonism.
Tectonics.
So these two styles, they're new. I mean, tectonism is a subsidiary style of parametricism. Parametricism started about 25 years ago, and evolved out of deconstructivism. So Hadid was the youngest deconstructivist, and then became maybe the oldest and most mature parametricist. And why we evolved this way? I mean, Zaha actually started early on in deconstructivism. She already was using some curves and get more and more into the use of dynamic curvature, and that's not arcs. That is very fluid curves where the radius continuously changes. So she was getting into that early on for a number of reasons. First, she loved the freehand sketch and wanted to make the building like that. And these sketches are very fast, like calligraphy. But also the deconstructivism compositions, they were very complex because you have complex urban sites and complex, rich building programs. And once you start, what we discovered, when we build up these complex compositions, that they become quite quickly illegible, meaning difficult to understand. They become quite chaotic. So to maintain legibility with complexity,
Mhm,
that's where
mhm,
curvature comes in, and not only curvature but also gradual transformations, so we call
mhm.
gradients. And also, instead of just clashing geometries, if they're different layers, they are correlated with each other. And that we did a lot more recently. Than we started to do that with parametric modeling with scripts, which make relationships between different parts. So one subsystem is a computationally derived, let's say, dependent variation from an underlying or different system. And so in deconstructivism, you had unrelated systems, and in parametricism, we have correlated system, and that
Mhm.
gives a feeling more of an organic, more nature-like design.
Yeah, thank you. It's quite complex and
But
yeah, yeah, I use
once you can see it quite easily with the eye. You can see the composition behind me. It has beauty, elegance, nature-like, but it also has a degree of complexity.
um the background is one of your work, I
The
guess.
background is an AI generated work, which I created with
AI
the help of an
generated.
AI system.
Oh yeah. Yeah, I used to study in ballet design for manufacture. It's like the hook park in for AA, I think.
Okay.
And what I did is best towards making the project lending to reality. We talk more about the parametric in the field of manufacture and design. So yeah, what I want to know is the goal and the value of parametric design, and not as a method or tool. It's a parametric design.
Yes, so the value is, first of all, we can talk about social functionality. That means that with the parametric design, you can adapt the form of the building more closer to the requirements. If you have an irregular site, if you have different levels, if you have different building components with different sizes, so we can, you don't have to fit all of this into a preconceived box or very simple form. We can make the form adapt and be as complex as the site and the program. So there's an advantage. So there's another set of advantages which come out of engineering optimization,
Yeah.
which comes to the detail. So if you have a long span structure, in modernism, you just make beams very straight. But if you optimize the beam would have a curve,
Yeah.
right? Or if it's cantilevered, it is also has a curved. You can use shells and tensile structures. They're highly optimized and they will always generate interesting curvature. So parametricism has the advantage, first of all, to fit the building better to the requirements. Second, to use engineering optimization. And therefore it is more structurally efficient, but also we can optimize, for instance, for environmental parameters. When you have a facade and you have different sun directions, you can gradually transform, for instance, the shading elements or the openings and adapt them to the gradual change in sun angle. And that way you can make something more optimized. And therefore, this parametric variation of the structural dimensions as well as of the, let's say, dimensions and elements makes the building more highly efficient and optimized. We also believe it's more beautiful.
Yeah. So, is it possible to parametric the factor in our society or economy or even capitalism, so we can design based on that?
Absolutely. So I'm a proponent of having more degrees of freedom for urban planning. So for instance, if you have a city map and you have different parcels, first of all, instead of making a rigid grid, we could vary the parcel size. We can adapt the lines of the grid, for instance, to a mountain, to a topography, or to a river, and gradually transforming from one curve of the river to a different curve of the mountain. So this way you have a parametric urban grid, but the economics comes in, for instance, if you develop the buildings and the value of the property will be higher in the center and less valuable in the side, more functions want to be in the center. So for instance, if you don't have any height restrictions from the government's point of view, you will have naturally the taller building in the center and a gradual falling off. And parametricism would predict that and would also show that. So you can translate, for instance, a land value map into a height map. That is a parameter of land value becomes a parameter of height, and you can therefore visualize and physicalize an underlying economic parameter. So that's within the idea of parametricism, based, for instance, on the urban condition.
Yeah, okay. Is it possible to design a parametric architecture like a box or like a Zumthor's work? Or...
Well, no, because some of these simple minimalist projects, modernist projects of somebody like Zumthor or David Chipperfield, they don't allow for any variation, and that means there's no optimization. You can only optimize the overall size but that's very limited. So the idea of optimizing and adapting, which is very central to parametricism, will mean that we will never, the natural outcome of a parametric optimization will never be a box. But what could be instead of one big box, we could have smaller rectangles or voxels and generate something like this. So you could doesn't mean that you have to have literally curvature everywhere. It's just variations with different degrees of scale, for instance, will lead you away from, for instance, a very rigid grid or box. So it leads us away from preconceived geometries to finding the geometry and letting the geometry follow. It's more of a closely form follows functions, and these functional parameters could be structural, could be environmental, but also social. And we, for instance, we also simulating with agent-based models the internal occupancy processes, and there you also see where the crowd is moving and where it is gathering into larger spaces, smaller spaces. Then when you have, for instance, corridors and circulation spaces, they're also not parallel. They might become larger if more inflowing coming in, and towards the end of the building where there's only few people going, it becomes narrower. And in the minimalism, you would just make one corridor. That corridor would be too small at one end and too large at the other end. So these kind of rigid geometries will always be inefficient and wasting a lot of space.
Yeah, like a tree or
exactly.
organism. Yeah. Patrick, last question is quite private. So, what's your first projecting work, and what difficulties did you make in design process or work?
Very interesting. So I mean, I worked on a number of competitions first, but the first design I was working on, which was built, was the Vitra fire station for the famous Vitra furniture company on their campus, and it was quite complex. It has different angles, it had different curves, and even three-dimensional curves. And the difficulty was, because at that point we didn't use a computer. This is 35 years ago. The difficulty was to try to draw and model in fact, we didn't, a complex geometry with an irregular curve in space. So that was a difficulty to draw that, and it wasn't easy. And so we had to kind of project the points over, project it from the ground, but then there was no way every drawing was just a flat projection, and the points, you had no 3D model, it's a digital model. So that was a difficulty, but there was a way for us to build it and get it done. With a lot of hand drawings,
with hand drawings. It had to do now. We all use Rhino or CAD to do it.
Yeah, we love Rhino. We're using a lot of Rhino and Grasshopper in particular. There's wonderful plugins, particular for tectonism. We need a lot of these special tools like Karamba, for instance, or Kangaroo, or different mesh relaxation models, and also so there's a lot of tools we can use over and above just Rhino modeling. We also work still with Maya as well for the early quick sketches, and then later on we also use BIM for the construction drawings. But we can also do a project fully on Rhino and Grasshopper.
Now we use more Safdie in Rhino than Maya.
Okay.
We appreciate for your sharing, Patrick.
Okay, my pleasure.
Good luck and take care.
So we are finished with the interview. So are we done?
Yeah, I think so.
Okay, great. Well, nice to meet you, and thank you for the very interesting questions.
Thank you. Thank you very much.
Bye now.
See you. Bye.